All right, how's it going, class? We are going to be doing Chapter 10 now. We're done completely with Chapter 9. As I told you last week, we're going to be moving on because we got a lot to cover. So, ready for some geometry? Of course we are. So, Chapter 10, what it's about, for the most part, is dealing with, what do you think it is? Well, it's not dealing with Homer Simpson, unfortunately, but you will see something, like a common theme here. So we're actually going from looking at 2D shapes. These are all like 2D stuff, right? Stuff that looks just like it's flat. And we're going into 3 dimensions. I don't know if you ever watched, at least I remember watching when I was a little kid. Actually, I wasn't that little. But I remember when they did an episode and they made Homer 3-dimensional. It was like a big breakthrough, I guess, because back then 3D wasn't that big of a deal. And so we're going from 2D to a 3-dimensional shape. Okay, so that's dealing with all 3D objects that you're going to be looking at, like 3D spheres or cubes or whatever it may be. And that's what Chapter 10 is about. So we're going to do 2 lessons in one, okay? Probably, hopefully, you'll be able to fit one on one side and the other on the other side, or just kind of, you should be able to squeeze it all in there, okay? So we're going to start talking about 3D figures first, or the solids. And we're going to first kind of go over some basic vocabulary here, okay? Now, I went ahead, again, if I'm talking too fast, pause, copy it, and then hit play, right? So here I actually have a 3-dimensional figure, okay? 3D figures, it says, are, or solids, are made up of, and there's 3 different things that at least the book wants you to remember, okay? And so in order to draw this, actually, and you're probably sitting there thinking, how on earth am I supposed to draw this, Mr. Puebla? You just copied and pasted a picture. Well, if you kind of want to learn how to draw this, and I'm sure you've gotten plenty of art lessons on this stuff, you can draw like a square like this, and then you can kind of do, I think the easiest one is to almost recopy the same shape, but kind of do it a little bit above it, to the side, kind of like that. See how basically what I did was I did the original one here, and then I just imagine like I retraced it, but I retraced it a little bit higher into the, maybe to the right of it. And all you have to do is connect the dots. So not connect the dots, I should say connect the vertices. There's 1, 2, 3, and 4. Okay. Now the one that I have here has dashed lines, so that's why it looks a little bit different, because these dashed lines are basically telling you that this is what's behind it, the thing that you can't see at all, okay? Whereas when they show you with solid lines like this right here, all this solid is basically saying that this is the visible part, okay? So hopefully you're able to draw something like that. Let's go ahead and discuss what these are. All right, guys, sorry about that. I had a minor interruption. So let's go ahead and label this what this is basically called. And this red area that you see up here, in a 3D shape, we're going to call these faces, okay? A face. And so a face is going to be basically like the flat side of any shape. So go ahead and label that as your face. And then let me show you, go ahead, what the other 3 call, or the other 2 are called. So I have a face up here. This is like a face, and this particular figure here has a face here, and here's another face here, this shaded, the square here, that's another one. Here's another face over here. There's a face underneath. There's a face to the left over here. There's a face back here. Oh, okay, those are all faces. Vertex are the points where they meet. Okay, there's tons of vertices here, I should say vertices. One right here, one right there, there, there's all over the place. And the edge are obviously the edge of like where 2 faces meet, for example, okay? So we have those 3 terms figured out. Again, if you need to, pause the video and record and copy down. So now next part I'm going to do is I'm going to actually talk about 4 common shapes you're going to be seeing, okay? So I'm drawing a thinking map here. And in the center you can write down 3-dimensional figures. And then what I'm going to do is draw 4 of the common shapes that you're probably going to be seeing for the most part, okay? So the 4 common shapes, let's start off with one of them, is going to be called a prism. And so let's just do like, I'll just write the word prism right here. I'm going to draw a picture right above it, okay? So a prism is basically formed by what? Well, let's do a triangular prism. Triangular prism, imagine you have like a triangle, and then you're basically drawing that same triangle like right above it. Okay, I'm just kind of sketching this out. So, and then it's connected by two parallel lines basically going up and down. Oh, that one's like too short, isn't it? And then this one you can't really see. So whenever you can't see one because it's behind something, then that's behind it. Oh, there's a beautiful bell. So there's that triangular prism. Okay, if you notice, how many bases does this thing have? I don't know if you can tell. This one actually has two different bases. Well, there's one down here, right? This would be considered a base. The triangle shape down here is a base. And then there's another one above here, right? Let me go ahead and color that in as well, too. And these are all bases. So I'm going to go ahead and just kind of label that as base. And then there's another base below. Okay, so that's one of them, a prism. And prisms can be just about any shape for the base, okay? And I'll kind of get into that by what that means in a second. Let's go to the next one. Let's do a cylinder. Cylinder is basically taking a circular base and then connecting the two bases. Kind of like a can, you know, any type of can you can think of. A soda can, a soup can, any type of thing, okay? We have circular bases, and then we have it connected. And these are circular again, so these are your bases. Here, let me just shade it in, and I'm going to say these are your bases. Okay, now we have a pyramid. Well, a pyramid kind of, for me, reminds me of like what a prism is, but instead of like a pyramid having two bases, imagine it just has one down here, and then all these lines basically meet up at one point. That's a pyramid. And there's different types of pyramids. So let me go ahead and write down, this will be the third one that I have here, pyramid. And a pyramid, for example, can have different types of bases. For example, it can have a triangular base. Okay, so just like the prism that I have drawn right up there. So this could be a triangular base, but instead of having another triangular base on the top, remember, it's just going to have like one point where they meet. And this point right here is called a what? Well, I basically wrote it out for you. This is a vertex. And so you have these lines that are going to meet up to this vertex that are coming from each one of these other vertices that are down here. Okay? So one base, let me color in my base. One vertex, that's a pyramid. And there's different types of pyramids, and I'll show you a picture right now of all those types of pyramids that we have. Okay, the next one that we have is a cone. Okay, you're going to be hearing a lot about cones later on. Cone is basically a pyramid, but instead what kind of base do you think it has? I hope you said circular. It's a circular base and then a vertex. And that connects back, and you're done. Let me shade in my base. And I have one vertex. Okay. So we got those things in mind set up. So these are basically your four main shapes: a prism, pyramid, cylinders, and cones. These are the most common ones we're going to be talking about in this chapter, okay? And just to kind of give you a little bit extra info, this isn't actually in your book. If you notice, here I'm just going to read along with you. You don't have to write any of this, just kind of for you to watch, see. A cube is a prism with 6 square faces. Well, there's other prisms and other pyramids, and they're all named for the type of shape that's on the base. So remember I told you that prisms could have different bases? Let me see if I can get my hand. I don't have a hand here. I should probably have a hand ready, shouldn't I? I can't believe I don't have a hand on this page. I bust out with a funky looking hand here. I'll do letter G. Letter G works. So I have a triangular prism, Remember, prisms have the same base on the top and the bottom, right? So triangular is like the one we just drew. It has triangular base and a triangular base, and they're connected like that, like that. Rectangular prism has a rectangle for a base here and a rectangle for a base. Pentagonal prism, well, guess what? Has a pentagon for the bottom and pentagon for the top. Hexagonal, hexagon for the bottom, hexagon for the top. And so that's what you end up with these prisms. Now remember, pyramids don't have two bases. They only have one, and then they meet at the point at the top. So here I have triangular, rectangular, pentagonal, hexagonal, right? And these can go on forever. We can do something with an icosagon. Do you guys remember what icosagon is? I don't know if you do remember, but even an icosagon can be a pyramid or it can be a triangular prism. An icosagon is 20 sides. Now, heck, I'm not going to be drawing something with 20 sides. Actually, you know what? This looks horrible. Let me try something else real quick. You're not drawing this, okay? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that was horrible. Anyways, well, let's not do an icosagon. Maybe 11 is hendecagon. And so if it was a pyramid, then these would all be connected up to a point, right? So something like this. So the base could be any shape. Obviously, the more sides that it has, the trickier it's going to see and the trickier it's going to look. So that's when you usually have to have the use of computers to help you do that stuff. Okay, back over here. So we're done with this 4 shapes, main common shapes. Now the last thing that I'm going to talk about here are nets. Now I'm sure you've seen about, maybe, I don't know if you have heard about nets already, but a net is basically, like, imagine a cereal box. And imagine if you were to just flatten that thing out, if you were to unglue all the sides and make it flat, what would it look like? That's what a net is. So go ahead and take a moment to write down the definition. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. Okay, now I have a net here, and I should be able to draw this, actually. This is pretty easy. It just looks like it's what? It's 5 boxes, 5 squares, basically all connected. And when these 5 shapes are folded, and maybe, let's say, glued or taped, but what are they going to make? And this is where you got to train your brain, obviously, to kind of say, oh, yes, Mr. Fowler, these are actually going to make a nice solid box, right? And that's what it ends up making, is a nice little solid box. And for those of you that are really good at shading, I used to teach my art kids all about the different shadows that a figure casts. There's your shadow. So a net is a three-dimensional, basically something that's flat, and then it can be folded back up to three-dimensional. So, for example, don't copy any of these down. These are just examples for you to kind of just think about. Okay, like these right here. Look at this first one right here that I have. Oh, let me bring this up. This one right here, what do you think this one it would fold up to be? Well, you have a circular, think of this as your base right here, your circle base. Let me see if I can bring this thing to the front. I have a circular base right here. And then imagine this is like the thing that folds around, like this little piece right here will get folded all the way around this thing, all the way and meet back up here. And hopefully you're able to say that this is going to make what? It's one of your 4 shapes that I have over there. Circular, circular, and then it's one vertex. This is a cone, right? And what about the next one over here? Well, you have a triangular base, and it looks like these 3 triangles on the side are going to meet up. Oh, going to meet up to the top and meet in one spot, and hopefully you know this is a triangular pyramid. Okay, something like that. All right, so those were just something else I wanted you to at least be able to practice with. Okay, the last thing I'm going to have you copy down for 10.1 is this definition right here of cross section. Let me bring down my hand real quick. I'm sorry. I'm going to need it. So a cross section. You're going to need to know that word because it's going to come up quite a bit when we do some questions later on, okay? A cross section is the intersection of a 3D figure and the plane. So here's the plane. Remember what a plane was? It's just like an endless like sheet basically. So like for example in this picture, when I intersect this, what kind of, well, let's see how many sides this is. This is 1, 2, 3, 4, 5. This is a pentagonal, what? Pentagonal cylinder, pentagonal pyramid, pentagonal, what is this? Let me go back up. Pentagonal pyramid, right? This is a pyramid, not a prism, it's a pyramid. Okay, so look at this pentagonal pyramid. It all meets up at a vertex, and all these edges come back down. Now, when I cut it, like imagine like you're slicing it thin with like a sheet of paper, what kind of shape is it going to create right here? That's kind of what you want to think about when I say the word cross section. If you were to take like a slice of it, like with a knife, you know, imagine this was the shape of a cheese, and you cut a thin slice out of this. What shape would you end up with? And this is going to be another pentagon. It's just going to be smaller. What about over here? This is a cone. Circular base, one vertex. And when I slice it, but the other way, when I slice it with a sheet of paper, but it's going up and down, and if I slice it, bam, right through there, look at what kind of shape it actually makes. It actually gives you a nice sliver of cheese. I think of it like cheese. A nice sliver of a triangle-shaped cheese, basically. That's what it's going to make when you do a cross-section. Now, feel free to copy any one of these down as a picture, just so you have practice drawing it. You know, if you want, draw this one right here, because it's probably the easiest one. And then we're going to move on, okay? And I think that's it for 10.1, right? The last thing I wanted to actually show you before we wrap this part of it up is this right here. I thought it was pretty neat. This is actually showing you net and how it looks basically. You know, imagine like you're working for a manufacturing company and you're in charge of making machines that are going to fold this thing in place. And so if you notice, let's see if it plays. If you notice, look how this net gets folded back up to basically make a box. Okay, and what about this one? Here's a net for a, well, it's got triangle bases, triangular prism, right? And when these bases fold up, except for those little red parts, obviously, those are kind of like little misleading. So imagine those little red parts weren't really there. But just imagine that you have like just the main part that I'm kind of coloring in right now. This would fold up to make a triangular prism. Okay. Oh, how about this fancy last one right here? Watch. It's pretty neat. Oh, let me move this out of the way. Look at this one, actually. This one's actually pretty neat. Talk about a milk box. Now, every time you drink a milk box, all you'll be thinking about is a geometric net. Look at that. That's pretty neat. All right, let's move on. Last little section that I have for you is on drawing. I like drawing. This is like a really neat one. But unfortunately, we have to kind of go really fast to do this. Okay. So it says there are many ways to represent 3D objects. Now you're probably writing these notes on the backside, okay? And that should probably be enough room to do this lesson. So there's 3 different ways that the book talks about how to draw 3D drawings, okay? One of them is called an orthographic drawing. Now imagine that I gave you a picture of like this shape right here. Now it looks like 3 cubes, you know, touching each other basically. And so if I ask you to draw an orthographic drawing, all I'm really telling you to do is, well, tell me what it would look like if I was looking at it straight from the front, like straight from this front. Like if I was standing right in front of it, like just looking straight on from right here, and here I am, like what would it look like? So we can do, let me go ahead and take the little man out of the way. So we're going to draw this from 6 different views, okay? We'll just do 6 different views. We'll say that from the front. This is where you start having to think with your right brain, okay? Your right brain is full of all your artistic abilities. It's just that a lot of you don't know how to tap into it. So from the front, all I'm going to be able to see is that. Okay, I hope this makes sense. Now, what about if I asked you what you would be able to see from the left side over here, from this side. So imagine now you're standing over here on this side, and you're looking this way, going that way. What would you see on the left side? Let me write the word left right here. And hopefully you're saying, well, Mr. Poet, you'd probably just be seeing the side of a box here and the side of a box here, like perfectly flat. And so that's actually another two shapes like that. And that's all you would be able to see. If you were standing flat, like let me draw a little person, and if you were looking straight that way, that's all you would see. You wouldn't see this side over here, or you wouldn't see this side, or you wouldn't see this side, or you wouldn't see this side. You would not see any of these. The only thing you would see would be the side over here in the front and the side over here in the front, right? Okay, what would it look like from the right over here? Just a quick drawing, and I hope you're seeing it. Look, this is all you would see, and this is all you would see. So I'm just going to draw a simple shape. It's actually a very simple one, okay? Except the only one that's really going to change is, well, what about, how would it look like from the bottom? And how would it look like from the top? Oh, so imagine you're hovering on top of this thing. Obviously, you can see that, look, 1, 2, 3. So from the top, it would look something like this. And what would it look like from the bottom? Well, from the bottom, similar as well too, right? You would see 3 boxes only like that. Okay? So this is called orthographic, where you're showing someone how it looks from all different angles. All right? That's one type of drawing. Let's go into the next one. This one's pretty neat, actually. Isometric drawing. And an isometric drawing, it's actually like, it utilizes, usually you can find, if you go online, you can Google isometric grid, and you can print out these sheets with like these dotted diagonal. It looks like they're all diagonal, like dots. Okay, and these are actually really helpful to help you draw an isometric drawing. So I'm going to take the same shape from above, but I'm going to show you how to make this isometric, how to draw it in an isometric view. Okay, and basically all you're going to do is, here's a little trick. Some of you who are bad at drawing, you're probably going to hate this lesson. But I'm going to start off with this side right here. Watch this, this edge right here, and I'm going to draw it. I'm going to start it right here. Okay, so let me start by doing that. 1, there's that line, there's that line. Now look, I'm going to go one at a time here. Now to draw this one and this one, well, I got to draw this other line like that, right? So to draw this one right here, well, that one's like the one right up here, right there. And so see how these dots are actually coming in really handy? And now to connect it, well, I'll just go this way. See how they're already done? Pretty much the dots are in the right place for you. And then what about if you want to draw this way, and this way? Okay, well, that's easy. Look, it's right here. Bam, bam, bam. Bam, bam, bam. Okay, see how you're starting to get the box shape now? Okay, and so now I'm going to do is, what else do I need to do? I need to draw another one further out, up, and over. Okay, that means that I need to expand this one, go this way, and go this way. And now you're probably going to have a hard time with this because I'm just thinking about it right now, and you don't have isometric paper. Although you do have one on the worksheet that I gave you, that the sub gave you in class. Okay, let me finish drawing this one this way. And now it looks like all I need to do is do the top part right here, right? Bam, 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 and just this shape. Basically, it's like an L shape up here, right? And look where it's at right here. Watch. Connect it there, connect it there, connect it there, connect it there, and you're done. Connect, 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 connect. Look how easily these dots make this job. And then I'm going to connect these, and I'm done. There's your isometric drawing. Okay, you can get really good at these. And I will give you guys a sheet of isometric paper so you can practice making really, really funky looking like block towers and stuff. Because you can kind of keep going this and make it even bigger. For example, I can keep drawing even more shapes on top of this thing like that. And now it looks like it's it's going up, right? You could even get fancy and shade in one side so it looks more three-dimensional. Right, so now it's looking even more 3D. So these actually help you draw, and you can keep expanding, and keep making this thing even longer, and so forth. But I'm going to stop right there. That's isometric. Here's the last one. Hopefully you've seen some of this in your art class. I'm going to draw a super simple, quick example, okay? Perspective drawing is really, really neat. I used to do so many projects in my art classes with this. So there's 1-point perspective, and there's 2-point perspective. We're going to do 1 point real quick. Here's how 1 point works. Draw a vanishing point. This is called the vanishing point. And let's just say we draw a, I don't know, I'm just going to draw a really weird shape. I don't care what kind of shape. It's a 3-dimensional shape. Now, this thing has 1, 2, 3, 4, 5, 6, 7, 8. Oh, I just made an 8-sided shape. You can make a box for all I care. It's just like a simple box. And then all you do is connect each vertex back to that point. Like that. Oh, this one stops right there because it goes behind it. And that's it. That's perspective, 1 point. Now, let me draw a different one, just so you guys can see it a little better. Let me draw a simple box shape. Okay, and let me go back to the vertex. That's 1 point perspective. Now, if I ask you to kind of slice it, you know, like a slice of cheese I told you, then I could actually do, watch what happens here. You slice it straight down here, and you slice this one straight across this way. You slice it in the same direction that this line is, and you slice it in the same direction that this blue line is. So I'm going to slice it that way. Slice, slice. And see how you end up with an actual cube? All you need to do now is erase these lines back here, like that. And you're done. That's a cube with 1 point perspective. Now, how does 2-point perspective work? Now, I'm not spending too much time on this, guys, obviously, because the important part, well, for geometry is really dealing with the math part of it, okay? You're going to be dealing with area, volume, surface area, but it's always fun to understand and know how to do these things just for the future. So here's how you would do a cube. Actually, you start off with like a straight line, like this. And when you're doing 2-point perspective, imagine like you're standing in the side, like imagine this is a sidewalk. And you're standing like right in the very corner of the sidewalk, and you're looking down both ways of a street, and you're looking at a corner of a building. That's how I always think about 2-point perspective. Okay, because then what you do is you draw from one vertex over to the vanishing point, and from the other vertex over to the other vanishing point, and the same thing over here. One vertex to the vanishing point, one vertex to the other vanishing point. Okay, and that's pretty much it for the most part. And then what you end up doing is, if you want to get fancy with your drawing, you draw this down, straight down, okay? And now, actually, to make this thing work really neat, watch. I'm getting really fancy here. You're going to take from this vertex, watch. From this vertex, draw it back over here. Let's see if we draw it this way. And then from this vertex, you draw it back over here. Oh, what happened there? That went out of there. Okay, draw it back this way. But look how I stop right there. And I'm going to erase now some of these little lines I don't need. I don't need this line right there. And I don't need this anymore. I don't need that anymore. I don't need that anymore or that anymore. And there's your cube. It's in 2-point perspective because one side, this side over here, or this side kind of went this way, and the other side went this way. Okay? It always went back to a point. So it was 2-point perspective. So that's kind of it, guys. I just wanted to give you a little quick introduction into 2-point perspective, 1-point perspective, into isometric drawings, and into orthographic drawings, okay? Hopefully you didn't have too hard of a time with that because it's mostly just drawing. That's all it is. There's really not much to it other than just kind of doing a lot of really neat looking drawings, okay? And I think that's all I got for you. How do you catch a 3D figure? How do you catch it? How do you trap it? With a net. That was pretty funny, wasn't it? Yeah, it was. All right, guys, hopefully you are able to write down all your notes, and hopefully if you have questions, please let me know. But hopefully this lesson was kind of easy. Okay, and I'll see you guys definitely on Wednesday, okay?